Oh, I started the live. Let's go, guys. Oh, it is freezed. All right. Let's unfreeze that. Hello, guys. It's gonna be a very long video because it's a what vulnerabilities. It is gonna be very hard. So, just so you know, I am a learner. So, I am gonna learn it now, what it is and everything here. Learning objective. I don't know any of this, so it may be a very long video. Like I don't know, but let's go. But we will read all everything and we will go through everything. Let's go. Auth vulnerabilities. Learn how Auth protocol works and master techniques to exploit it. Introduction. In modern web application, Auth vulnerabilities emerge as a and serious and frequently disregarded risk. When we talk about Auth, we talk about Auth 2.0, a commonly used authorization framework. The vulnerabilities occur when hackers take advantages of weakness in Auth 2.0, which allows for CSRF, SSS, data leakage, and exploitation of other vulnerabilities. Learning objective. Throughout this room, you will gain a comprehensive understanding of the following key concepts. Essential concept for Auth 2.0 grant types, Auth 2.0 flow, identify Auth service, exploitation technique, evolution of Auth 2.1. An understanding of the following topics is recommended before starting the room. We know how websites work, right? A bit of we know that. We know the protocols and servers, and we know Auth was top 10. Let's go. I am ready to start the room. Huh? We skipped 9 to direct 13. I like it, I like it. Let's go. Key concept. This task will discuss the key concept of understanding Auth, specifically Auth 2.0. This concept from the foundation for understanding how Auth 2.0 framework was built as a penetration or a secure coder. It is essential to understand this concept to pen test a website or write code without a vulnerability. To make this concept more relatable, we will explain them through a daily routine example using a coffee shop's mobile app to order and pay for coffee. Resource owner. The resource owner is the person or a system that controls certain data and can authorize an application to access that data on their behalf. This concept is fundamental as it centers around user consent and control. For example, you are the resource owner as a coffee shop customer. You can control your account information and grant the coffee shop's mobile app permission to access your data. Client. The client can be a mobile app or a server-side web application. It acts as a intermediary requesting access to resources and performing actions as permitted by the resource owner. For example, coffee shops web app which you use to order and pay for the coffee is the client. You, your authorization is needed to access your account details and payment information. Let's zoom in a bit. Yes. Uh, is it very big? No, right? Let's go. Wait a sec. Uh, is the client your authorization needed to access your details and payment information? That is client. Now, authorization server. The authorization server is responsible for issuing access token to the client after successfully authenticating the resource owner and obtaining their authorization. The authorization server plays a crucial role in auth process by ensuring the client is granted permission only after legitimate user authentication and consent. For example, the coffee shop's backend system that handles authentication and authorization is the authorization server. It verifies your credential and grants the web app permission to access your account. Resource server. The server hosting the protected resources can accept and respond to the protected resources request using access token. This server ensures that only authenticated and authorized client can access or manipulate manipulate the resource owner's data. For example, the resource server is the coffee shop's database that store your account information, order history, and payment details. It responds to the request from the web app, allowing it to retrieve and modify your data. Authorization grant. The client uses a credential representing the resource owner's authorization to access their protected resource to obtain an access token. The primary grant types are authorization code, implicit resource owner password credentials, and client credentials. For example, when you first log into Shopee Coffee Shop's app, you are given an authorization grant like entering your username and password. The app uses this grant to get access token from the authorization server. We will discuss in detail in the next task. Then there is access token, a credential that the client can use to access the protected resource on behalf of the resource owner. It has limited lifespan and scope. Access tokens are essential for maintaining secure and protected communication between the client and the resource server without repeatedly asking the resource owner for credentials. For example, once you logged into the coffee shop's app, it receives an access token which allows the app to access your account to place order and make payments without asking you to log in again for specific period. Refresh token, a credential that the client can use to obtain new access token without requiring the resource owner to re-authenticate. Refresh tokens are authenticate. Refresh tokens are typically long-lived and provide a way to maintain user sessions without frequent login interruption. For example, when your access token expires, the web app will use a refresh token to get a new access token, so you don't have to log in again. Redirect URI. The URI to which URL redirect to URL. Alright, URI not. That is completely changed URI. Yes. The URL to which the author authorization server will redirect the resource owner's user agent after the grant or denial of authorization. It checks if the client for which the authorization response has been requested is correct. For instance, after interacting with the coffee shop app and logging in, you will be redirected to authorization server by the app page in the coffee shop's app. commonly known as redirect URL, to confirm that you are successfully logged in. Scope. Scopes are a mechanism for limiting an application access to the user's account. They allow the client to specify the level of access needed and the authorization server to inform the user what access level the application is requesting. Scopes help enforce the principle of least privilege. For example, the coffee shop's app may request different scope, such as grant to your order history and payment details. As a resource owner, you can see what information the app requests uh, to access requests access to and grant or deny any permission. Wow. State parameter. An optional parameter maintains state between the client and the authorization server. It can help prevent CSRF attacks by ensuring the response matches the client's request. The state parameter is crucial part of securing the auth flow. For example, when you initiate the login process, the the coffee shop's app sends a state parameter to authorization server. This parameter helps ensure that the response you receive is linked to your original request, protecting against the certain types of attacks. Token and authentication endpoint. The authentication server endpoints is where the client exchanges the authentication grants or a fresh token for an access token. In construct, in construct, the authorization endpoint is where the resource owner is authenticated and authorizes the client to access the protected resource. By familiarizing yourself with the topic, you will easily understand the exploitation technique and associated vulnerabilities in the upcoming tasks. Let's see which one we learned. It was resource owner, client, authorization server, resource server, authorization grant, access token, refresh token, redirect URL, scope, state parameter, token and authorization endpoint. Which optional parameter can be used to prevent CSRF attack? That is scope, right? No, it is state parameter. STATE. Nice. What credential can the client use to access protected resources on behalf of the resource owner? What credential can the client use to access the protected resources on behalf of the resource owner? Uh, this one maybe. Access token. Authorization at point is where the client exchanges authentication grant or access token. In contrast, the endpoint, where is this? Here it is. The credential that the client can use to access the protected resources on behalf of the resource owner. Here it is. Let's see. That is correct. Oh, oh my God. Let's see. Auth grant types. Auth 2.0 provides several grant types to accommodate various scenarios and client types. These grant types defines how an application can obtain an access token to access protected resource on behalf of the resource owner. In this task, we will discuss four primary Auth 2.0 grant types. Authorization code grant. The authorization code grant is a most commonly used 2.0 flow suited for server-side application, PHP, Java, Net, etc. In this flow, the client redirects the user to the authorization server where the user authenticates and grants authorization. The authorization server can then redirects the user to the client with an authorization code. The client exchanges. the authorization code for access token by requesting the authorization server token endpoint. Resource owner access application will go. This is application. Resource owner access application. Authentication and authenticate and request authorization. Authentication and grant authorization to server. Send authorization code to application. Uh, Application request code exchange for token. Server request resource with access token. No. This one server issues the access token. Then application requests resource with the access token to the resource server. Oh, this is another one. Here, here we get the access token and all. Resource will be in another server. Wow. And resource server will return the source to the application and it will give to that. The grant type is known for its enhanced security as the authentication authorization code is exchanged for access token server to server, meaning access token is not exposed to the user agent, thus reducing the risk of access token leakage. It also supports using refresh token to maintain long-term access without repeated user authentication. Implicit grant. The implicit grant is primarily designed for mobile and web application where clients cannot securely store secrets. It directly issues the access token to the client without requiring an authorization code exchange. In this flow, the client redirects the user to the authorization server after the user authenticates and grants the authorization. The authorization server returns an access token in the URL fragment. The URL fragment. The complete flow is shown below. Resource owner, application, authorization server, and resource server. Resource owner, resource owner access the application, authenticate and authorization request. Uh, Resource owner authorization and grant authentication and grant authorization to the authorization server. Issues a token in URL to application. Then request resource access token in URL to resource and then it returns. This is a bit confusing. Let's see what was this. Authorization code grant. They send code. It's the same process, right? Send authorization code, request code exchange for tokens, issue access token. Here, impact grant, issue access token in URL, request resource with access token in URL. Oh, this is very easy, I guess. Issue access token in URL. It has only two process. It requests resource, it directly send. It has three process. I don't know, man. If you understand it better, you are great. I am not. This grant type is simplified and suitable for client who cannot securely store client's secrets. It's faster as it involves fewer steps than the authorization code grant. Oh, it easier. It is just two steps. It only asks this one token. We ask this and it gives them then directly. But here it's an authentication code. It exchanges the token. Request code for. Oh, wait a sec. Wait a sec. Oh, here it sends this and then it's an authorization code, request code, exchange for token, and issue. It's lots of stuff. Now let's see. However, it is less secure as the access token is exposed to user agent and can be logged in the browser history. It also does not support refresh tokens. Wow, it has its setbacks. Resource owner password credential grant. The resource owner password credential grant is used when the client is highly trusted by the resource owner, such as first-party application. The clients collect the user credential, username and password directly and exchanges them for the grant for an access token as shown below. Authentication username and password is go to application, send username to authorization server, issues access token, request resource with access token, return resource. Wow, this is very simple. In this flow, the user provides their credential directly to the client. The client then sends the credentials to the authorization server, which verifies the credentials and issues an access token. This grant type is direct, requiring fewer interactions, making it suitable for highly trusted application where the user is confident in providing their credentials. However, it is less secure because it involves sharing credentials directly with the client and is unsuitable for third-party application. Client credential grant. The client credential grant is used for server-to-server interaction without user involvement. The client uses its credential to authenticate with the authorization server and obtain an access token. In this flow, the client authenticates with the authorization server using its client credential, client ID and secret. The authorization server issues an access token directly to the client as shown below. Client credential grant. Let's see. Application authenticates client ID and secret. Authorization server issues access token. Request resources with the access token. Resource server returns the resource. It is also very easy. Similar to this one, right? It has this application, but in this everything directly happened. This process is cut out. This grant type is suitable for backend servers and server-to-server communication as it does not involve user credentials, thus reducing security risk related to user data exposure. The next task will show how the auth flow works within the web application. Wait a sec. We learned how much? Three, right? Authentication code grant, implicit grant, resource owner password credential grants, and client credential grant. Mm, what is the grant type often used for server to server interaction? That is the last one. Client credentials grant. Wait a sec, guys. I am gonna drink some water. Wait a sec. It is in. Uh, I am gonna come back soon. Sorry, guys. I was sorry for that, guys. I went to drink some water. Now let's continue this. Sorry. How auth flow works. Let's see. The auth 2.0 flows begins when the user resource owner interact with a client application client and request access to a specific resource. The client redirects the user to the authentic authorization server where the user is prompted to log in and grant access. If the user consents, the authorization server issue an authorization code which the client can exchange for an access token. This access token allows the client to access the resource server and retrieve the requested resource on behalf of the user. Let's see. Bob trying to access his account orders. This is application. Redirect to login screen. Uh, Bob login and grant access to resource. Returns auth code to the application and then send auth code along with the client details to the auth server. Auth server grant access token or refresh tokens to the application. Then it use the token for is token from the step 6 and request the data from server. We will discuss the various steps of auth overflow in details considering the same coffee shop app example. Let's see. There is many thing. Is it booted up? Why it is? Restore session. Yeah, we are in. That is what needed, right? Let's see. You can start the machine. All right. It is right here. We will use a customized version of Django. Django. The Django. I don't know it what artist is pronounced. The Django auth toolkit for auth provider. It is very important to understand that when the term auth provider is used in the upcoming task, it means the third party auth provider which with which we want to integrate and authenticate. For example, in the case of login with Factbook, Factbook is the auth provider. Moreover, in this task, the auth provider, the coffee shop app, would remain the same. However, the client, the app we want to integrate will change in each task. You can visit the URL to see the logging panel for auth provider, which would remain the same throughout the room. Let's see, we will do that. We are in there. Well, let's see. My best. Yeah, it is this one. Let's see. We will be using the following credential for the auth provider in this room. Victim123, username victim123, and the password that is, huh? Oh, we are using two different credentials. We will using following credential. Note you are required to log in at this stage, but later this task you can use the above credential to log in. Once logged in as your auth provider, you can log in log in on any other website just like you perform. Sign up with Google or X, Facebook or any other website. Now visit the Visro THM 8000 URL, which we will use to understand the workflow. We will understand the workflow by considering a person named Tom. You can use any of the above credential for him who would like to log in the different website app using his copy shop account. Wait a sec. Username, a sec, copy, uh, victim, right? I guess that is correct. Hope so. Paste. Wait a sec. It might be wrong. I don't know. Let's remove this 1 2 3. Let's, yeah, we can log in here. Welcome to coffee shop. You don't have permission to view or edit anything. All right, let's see. We need to go here. What the hell? Why this page changed? Oh, it's here. All right. These are the same, I guess. Let's put it that way. Log in with auth. Let's see what were they trying to say. Authorization request. Tom first visit URL where he wants to log in with a coffee shop app. When he clicks login Viva Auth, coffee shop app must first obtain his permission. So the application redirects Tom's browser to the authorization server and the authorization request. Let's see. Oh, it sended us. It redirected us to 800 authorization something client ID. There is this. Yeah, this one. Click on the auth. You will redirect to the authorization server shown below. All right. The Wipro website initiates this process by redirecting Tom to the authorization server with the following parameter included in the URL. There is a parameter, let's see, response type code. Uh, am I not seeing? Here it is. This is encoded, alright. Then there is, this indicates that the copy shop app is expecting an authorization code in return. State a CSRF token to ensure that the request and response are the part of same transaction. Mm, What is this state? I cannot see it. Uh, State. Let's see. We can see it here. Uh, React URL. I do not see. Client ID. What the hell is that? I did missed. No. There it is. I don't understand what is this state they are mentioning. We will use some chatbot. Oh, wait a sec. We will use some bracket. Oh, it look simply a random unique string your app generates before redirecting the user to authorization server. The echo back to your callback. You can verify that response belongs to the same user session. It should be the state, but I do not see the state. Am I tripping? This is client ID. And then there is response type, redirect, or maybe I don't know if there is no state idle, right? Then there is client ID. We saw that client ID. This one. Uh, a public identifier for client application, unique identifying of redirect URI. URI, the URL where the authorization server will send the DOM after he grants permission. This must match one of the pre-registered redirect URLs for the client application. Scope specify the level of access requested, such as viewing the coffee orders. Mm, let's see. By including this parameter, the Bistro app ensures that the authorization server understands what is requested, where, where to send the user afterwards. Here is the Python code that directs the user to authorization server. The auth login request app application object get. If you understand this, you are great. Redirect URI request get. They always add here that explaining the code, but there is no redirect URI. Oh, they are mentioning it here. Redirect URI code and authorization URL. That is this one. Let's see. Authorize. This is client ID. Response type. Redirect URI. There is nothing that is that state authorization, authentication, and authorization. When Tom reaches the authorization server, he is prompted to log in using his credential. This step ensures that the server can verify his identity. After successfully logging in, the authorization server asks the Tom if he agrees to grant the Bistro app access to his detail. This, this constant step is crucial as it gives Tom transparency and control over which application can access his data. The process typically involves User login. Tom enters his username and password on the authorization server login page. Constant prompt. After authentication, the authorization server presents Tom with a consent screenshot detailing what coffee shop app request access. Viewing his coffee shop orders. Tom must then decide whether to grant or deny this permission. Application requires following permission. Read scope, write scope. This two-step process ensures that the Tom's identity is authenticated and is explicit content consent is obtained before any access is granted, maintaining security and user control over personal data. Authorization response. If Tom agrees to grant access, the authorization server generates an authorization code. As also discussed in the task 4, the server then redirects Tom to the Bistro website using a specified URI. The redirect include the redirection includes the authorization code and the original state parameter. I missed it. Ah, here it is. The redirection includes the authorization code and the original state parameter to ensure integrity of the flow. The authorization server responds with the following code: coffee shop we will use authorization code to request the access token. State the CSRF token previously sent by coffee shop app to validate response. An example authorization response would be bistro callback code auth code 1234 state. Wow. In this step ensures the authorization process is secure and response is linked to the bistro's initial request. The authorization code is temporary token that will used in the next step to obtain access token, allowing coffee shop app to access Tom's profile details. Token request. Authorization response. It gets in the response, alright. We do not find that because it is requesting, not the response. We will see the response in the how to say, I don't think so we can see it here. Maybe we can see it in burp suite, something like that. In raw form we can see. Maybe here we can see. Let us check. Is this the one? Client ID, it is request. This is the response. Static. No. Uh, I don't know, guys. We will see. We will show us where we can find it. Then is token request. The Bistro website exchanges authorization code for an access token by requesting authorization server's token endpoint through the post request with the following parameter grant type uh, type of grant being used. Usually it's set as code to specify authorization code as a grant type. Code authorization code received from the authorization server. Redirect URI. This must match the original redirect URL provided in the authorization request. Client ID and client secret. Credential for authenticating the client application. Using the above parameters, the following code will make a token request to zero token endpoint. Let's see, there is this they given uh, token URL. This one client ID, application object, client servers. This is very hard for me to understand, but they get this much data. Data is equal to grant type, code, react URI, client ID, secret. These are the headers. Content type, authorization, F basics, base 64 encoded. Hmm. The Bistro app secretly exchange the authorization code for access token by sending this request. The authorization server will verify the information, providing ensuring the request is valid and originates from the client requesting authorization code. If everything is correct, the authorization server will respond with the access token, allowing the Bistro website to proceed with accessing Tom's profile details. Token response. The authorization server authenticates the Bistro website and validates the authorization code. Upon successful validation, the code responds with the access token and optionally a refresh token. The authorization server response includes the following: access token, content type, expires in refresh token optional. Access token that will be used to access Tom's details. Token types, typically bearers, uh, expires in duration in seconds for which the access token is valid. Refresh token, a token used to obtain new access tokens without requiring the user to log in again. With the access token, the Bistro website can authenticate the request to the resource server to access Tom's profile details. The optional refresh token can be used to request a new access token once the current one expires, providing a seamless user experience by avoiding the need for Toms to log in repeatedly. The Bistro website has completed the Auth 2.0 authorization workflow. In the access token workflow, with the access token, this token is credential allowing the access app to access protected resources of on Tom's behalf. Now the Bistro website can make authenticated requests to the resource server to retrieve Tom's profile. Each request to resource server includes the access token in the authorization header, ensuring that the server recognizes and permits the access. Uh, we learned this authorization request. Then there is that is authentication request. Then that is authorization request. This token response. What is called the client ID value after initiating auth to find workflow? That is we given here, right? Do we need to take from there? But here it is client ID. Uh, I guess that is the one. I don't know. Yes, it is. What parameter name? What parameter name determines the time validity of the token in the token response? That is refresh token or expires in token or it will give a new token, but sorry about that. Oh, it is very short. No, it is big, but compared to other it is short. Let's see. Identifying the auth service. How we can identify the auth services? Let me drink some water. Identifying auth usage in an application. The first indication that application uses auth is often found in the login process. Look for options allowing user to log in using external service provider like Google, Facebook, and GitHub. These options typically redirect user to the service provider authorization page, which strongly signals that the auth is in use, like TryHackMe. TryHackMe has that, right? I am logging in Google, I guess. Detecting auth implementation. Auth implementation detecting. When analyzing the network traffic during the login process, pay attention to HTTP redirects. Auth implementation will generally redirect the browser to authorization server's URL. This URL often contains specific query parameters such as response time, client ID, redirect URI scope, and state. These parameters are indicative of an auth flow in process. For example, the URL might look like this: Dave Coffee authorize response type, client ID, Redirect URI, state code. Cope. What is cope? Scope. Sorry about that. I read it wrong. Identifying the auth framework. We know two types now. This one, identifying auth using application, detecting auth implementation. Then there is identifying the auth framework. Once you have confirmed the auth is being used, the next step is to identify the specific framework or library the application employs. This can provide insight into potential vulnerability, the appropriate security assessment. Here are some strategies to identify the auth framework. HTTP headers and requests. Where it is. Inspect HTTP headers and response bodies for unique identifier or comments referring specific auth libraries or framework. Source code analysis. If you can access the application source code, search for specific keyword and import the import statement that can reveal the framework in use. For instance, libraries like Dongjo Auth Toolkit, Auth Spring Security Auth, Passport, or Passport in Node.js each have unique characteristics and naming convention. Authorization and token endpoints. Analyze the endpoints used to obtain authorization code and access token. Different auth implementations might have unique endpoint patterns or structure. For example, Dongjo, Dongjo auth toolkit typically follows the pattern auth authorize and auth token, while the other frameworks might use different paths. Error message. Custom error messages and debugs output can inad- inadvertently reveal the underlying technology stack. Detailed error message might include reference to specific auth libraries or framework. Identifying auth framework. What is the name of the toolkit used for implementing the auth in the URL? Wait a sec, we will see. Is the question mark valid? Let's see. Let's see. Uh, uh, view source code, and they said to search all this, right? The source code. You can make a notes and write that. Let's see. Paste. Not found. All right. There is not found. Copy. I got it. Sorry about that. It is very laggy for some reason. Why is this not copying? Copy, paste. There is not it. Here it is. Auth demo. Is that it? Auth demo. It is very big. Maybe let's see this one. Wing security auth. Oh, how am I supposed to find that? We tried all. I don't think so. That is a password. Let's read the question. What is the name of the toolkit used for implementing auth? Wait a sec, wait a sec, wait a sec, wait a sec. We need to find its toolkit, right? Wait a sec. Uh, let's see some techniques here. Inspect HTTP and response bodies for unique comment referring to specific libraries or auth framework. Maybe this one, right? Libraries, but I cannot find that. For instance, libraries like I did not find this, but let's try it. It is as a name toolkit. Yeah, it is the answer, right? It fit perfectly. Auth, oh, here it is a pattern. Authorize, auth token. Let's see if there is that pattern. Let's see. We found it here, right? There is no pattern. I, guys, I don't know how it is this one, but here you can see it, right? The toolkit and this in toolkit here. So I matched that. You can see they are making it easy for us by giving that this one. See, we know now flag will be not this much big, not this much big. It is this much. Oh, now there is a flag challenge. Let's go. Exploiting auth, stealing auth token. Let's see. Tokens play a crucial role in the auth 2.0 framework, acting as digital grant to protect the resources. These tokens are issued by the authorization server and sorry and redirected to client application based on the redirect URI parameter. This redirection is crucial in the auth flow, ensuring that tokens are securely transmitted to the intended recipient. However, if the redirect URI is not well protected, attacker can exploit it to hijack tokens. Let's see. Role of redirect URI. URL is URI then. The redirect URI parameter is specified during a auth flow to direct where the authorization server should send the token after authorization. This URL must be pre-registered in the application setting to prevent open redirect vulnerabilities. During the auth process, the server checks that the provided redirect matches one of the registered URIs vulnerability. An insecure URI can lead to severe security issues if attacker gain control over any domain or URL listed in the redirected URI. They can manipulate the flow to intercept tokens. Here's how it can be exploited. Coffee shop app client ID, user 1, redirect bistro auth demo callback, attacker strategy. If the attacker gain control over dev distro THM, they can exploit the auth flow by setting redirect URI to the HTTP dev distro THM callback. The authorization server will then send the token to this controlled domain. Wow, 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 wow. Crafted attack. The attacker initiates a workflow and ensures the redirected URI points to their controlled domain. After the user authorizes the application, the token is sent to this one. See in this, it's go to Bistro THM 8000. It go now it's they changed this call back to this one, this domain. This domain is they compromised. The attacker gains access. Token is sent to this one. The attacker now captures this token and use it to access the protected resources. Very handy, I guess. Mm, but you need to access get the access of this to do this all this. It's not easy, that's for sure. Preparing the payload. Before starting the exercise, please please ensure you are logged out of auth provider as a victim by visiting the link. Uh, Wait a sec. Da, 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 uh, uh, I don't know why, but oh, it freezes. I cannot copy for some reason. It's my keyboard not working. Yeah, we logged out, right? We are still logged in. Their link does not logged out. We have to log out. For this exercise, we assume that the attacker has compromised the domain. See, you need to compromise this domain to do this. If you don't know how to compromise, you are finished. Like me, I don't know how to compromise. If it's an easy one, maybe I can. After all, I did complete some of the rooms that did the same. And host can wait a sec. We assume compromised and can host any HTML page on the server. Consider Tom a victim to whom we will send a link. The attacker can craft a simple HTML page, redirect URI HTML with the following code. From action, HTTP coffee THM 8000 auth demo auth login. Method get input type hidden name redirect URI value uh, input submit value hijack auth. This form sends a hidden redirect URI parameter with the value this one and submits a request to auth demo auth login. The malicious redirect HTML page then intercept the authorization code from the URL using the following code. Script extract the authorization code from the URL. Constant from URL param. New URL search Windows location search. Get code. Document get element by ID auth code. Intercept authorization code. Code to save acquired code in the database or file, etc. Note since that Note since the attacker has complete control over the subdomain, once he redirects a victim to the attacker's controlled domain, he will save the credential in the database file, etc. for later usage. Moreover, the redirection from redirect URI to the original URL would be so quick that the victim would have no idea that his authorization code has been hijacked. The attackers can send Tom the link redirect URI through social engineering tactics or a CSRF attack. The victim, unsuspecting of the malicious intent, clicked on the link, which takes them to the dev restore directory. In the attached VM, open the link in the browser as victim. Here you will see the following screen. Let's see. I don't know. Let's see. We will see that something like red was there. Why it is spinning so bad? Why is it crash out? Why, man? Why? Maybe something happened. I don't know. Maybe I should use open weapon in this. Oh, I didn't add HTTP, so that was spinning so bad. If this is not working, you can go with this. All right, you need to add this. Let's see. As we see this in the attached VM, when the victim clicks login via auth bottom, the form calls to HTTP auth demo auth login, but with a falsified redirect URI. Once the victim enters this credential, victim 123 for auth provider, it directs the auth authorization code to the attacker's controlled URL. HTTP reduce malicious redirect HTML, allowing attackers to intercept and misuse the authorization code as shown below. Let's see. We will do this first. Let's try that. We need to log in. We will log in as victim, and then there is victim 123. Let's try it to log in. Not now. Please enter the characters. I don't know the spelling, man. Victim, victim, what's wrong here? Vic, let's see. I will copy this. Sorry, guys. I am bad with spellings. Paste victim. Why it is not pasted there? Is Control V? Control V. Something is happening there. Let's see the spelling. Victim, victim, victim. Alright. Now, victim 123. Let's try. Not now. Yes. Uh, but with false flags category once we contested See, we need to authorize to be redirect as redirected intercepted authorization code. This is authorization code. Let's see. Attacker's perspective. From the attacker's machine, they can utilize the intercepted authorization code to callback endpoint and exchange it for a valid access token. In the auth flow we saw earlier, the callback endpoint is always available, accepting the code parameter and returning the access token. With this token, the attacker gains unauthorized access to the user protected resource to get access token. Visit this see and replace the code parameter with the alright. I need to go to this and I need to change this number in here. Let's see, paste. Yeah, we got it. We got the access token. Oh, this is the access token. No, then what the hell is this? Uh, oh, this is authorization code. We need that code to get it. This page. Let's see. And replace the code parameter with the acquired authorization code. That is the flag. You can see we got this one. Access token expires in 36,000 seconds. How much is that? 36,000 in 6,000 suck in min. It is a minute, right? 600 minutes. That's a 10 hour. Oh my god. Uh, da, 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 da. Du, 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 du. Let's dance. Now we are in exploiting auth, stealing auth token. We steal the token here. We, how do I say? We add compromised this subdomain and we redirected the URL to this this subdomain. It was already compromised subdomain, so we got the code in intercepted domain. Intercepted. We got the domain in or compromised subdomain. Then we intercepted the uh, redirect redirection. This one, and we send using code. We got the code and we used this. I understand a bit, not much, but bit. Oh my god, why did I scroll down? There was so much to read. Let's see. Exploiting auth CSRF in auth. The state parameter in auth 2.0 framework protects against CSRF attacks, which occurs when an attacker tricks a user into executing unwanted action on a web application where they are currently unauthenticated. In the context of auth, CRF attack can lead to unauthorized access to sensitive resources by hijacking the auth flow. The state parameter L mitigates this risk by maintaining the integrity of the authorization process. Vulnerability. Vulnerability of weak or missing state parameter. The state parameter is an arbitrary string that the client application includes in the authorization request. When the authorization server redirects the user back to the client application with the authorization code, it also includes the state parameter. The client application then verifies the state parameter in the response matches the one in it initially sent. This validation ensures that the response is not a result of CSRF attack but a legitimate continuation of auth flow. For instance, consider a auth implementation where the state parameter either missing or predictable static value like state or a simple sequential number. An attacker can initiate a auth flow and provide their malicious redirect URL. After the user authenticates and authorizes the application, the authorization server redirects the authorization code to attackers controlled URI as specified by the weak or absent state parameter. Practical. In this exercise, we will explore how the absence of the state parameter in the auth authorization process can lead to CSRF attacks. You will need to use the attack box to understand the attack from both attackers and victims perspective. We will be using the app My Contact THM 8080 app that allows you to sync contact from any platform. If we need attack box, let's see. Before starting the exercise, please ensure you logged out of the auth provider as a victim by visiting. Alright. Start the attack box by pressing attack box button on top of this task. The machine will start in split screen view. In the case of VN is not visible, use the blue button shown in the split view button at the top. That you know that, right? You will be required to add my contacts THM and coffee THM to its host file. Alright. We will do that. Let's see. Which one we do not need it? We do not need this. Uh, we need to log out, right? Wait a sec. It is. What is this? We do not need this. Let's see. Uh, let's see. Uh, I need attack box. Let's see. It is not loaded up. Yeah, it is loading. We need my contacts THM. Let's see. Yeah. Firstly, I need the IP. You can use nano, right? etc HOSTS host, right? etc hosts. I forgot that, and let's see. Only two, right? My contacts, it is this one. Only two we need to for now. Let's save it. Control 0 and Control X. Yes. Let's see. Uh, we will be using the app. Let's go to the app. Copy, paste. Ah, sorry. I know I am dumb. Sometimes I shock myself. Sync status from coffee shop app. Wait a sec, guys. I'm gonna pause for a minute. Uh, Sorry about the pause, guys. Let's continue. Uh, we are in there, right? Sync contacts. Sync status from the coffee shop app. We got the login page. Let's see. Uh, Search data box. That is we done. Focus perspective. We gone. Let's see. If you click on the sync contact button, you will be redirected to the authorization server with the URL. Let's see. We got that. Yes, we got that. As a pentester, you will notice that the authorization URL is missing. Authorization URL is missing. I did not see that. Yeah. Oh my god. I think I am a great man, dude. I before I searched for this state thing, I did not find it. So here it is not there. They are telling as a pentester. I am a pentester. Happy, happy, happy. As a pentester, you will notice that the authorization URL is missing the state parameter, suggesting we can use the same request for CSRF attack here. You don't need to sync your actual account. Let's exploit this vulnerability to attach the attacker's third party account to the victim's account, exploiting the vulnerability. Without the state parameter, the authorization process is vulnerable to CSRF. The attacker can exploit this vulnerability by obtaining the victim's authorization code and sending it to the attacker. The authorization server won't have any way to determine whether the authorization code belongs to the attacker or the victim, or whether the request is coming from the attacker or the victim. Preparing the payload. To prepare the payload, attacker must get his authorization code. This can be done by intercepting the authorization process using tool like Burpsuite or any other network interception tool. For the sake of this exercise, we will provide the link that allows you to get your authorization code without completing the auth flow. The code for the flow is pretty straightforward as shown below. I am not a code expert, but let's see. Uh, well, I am not a code expert, let's forget it. I need to, guys, one of the biggest thing is that I learned, if you are a hacker, you need to understand what is written in there. I am still not there. Let's see. Someday, do I need to log in? Why it is not getting anything? You will get the following response once you visit the shared. Oh, we need to use this attacker test 123. Test not Tesla at 123. Let's see. Paste uh, Tesla at 123. Let's see. Not now. Authorize. Yeah, we got this. We got the code and we got the payload. Let's see what they tell. The above authorization code would enable anyone to get an access token against it. The URL, the URL parameter in the response is an actual payload that we need to send to the victim. Copy the payload value we can we will use the while launching the attack. Wait a sec. I need to understand how it is happened. Uh, this was the code. How did they change? 800 authorize response type code client ID. It's all the same. Redirect URI. It's all the same, right? No, 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 no. Yeah, something changes here. Coffee shop THM. HTTP. Coffee shop THM. Wait a sec. Wait a sec. Wait a sec. Wait a sec. I need to understand that. What the hell is that? This simple URL coded version. When the URL is placed inside the query parameter, for example, it must be URL encoded to. Why this code appears to be yes, sir. This URL is likely callback endpoint where the authorization server redirects the user after authentication. It's where the authentication or token is returned. The state parameter validates to prevent CSRF. Your application verifies the request. In the CSRF lab contrast like TryHackMe, this endpoint is usually where victim is redirected after clicking the malicious. This is the CSRF is a code CODE. Let's see. It isn't a code by itself in the URL. The part CRF. Oh, yes, yes. All right. Now I get it. It's a, in this case, this CRF is this one. It collects it and it's do this one PSP. Right? That is what it says. Right? Yeah, forget it. I understand bit by bit. I fully don't understand. Let's see where we are. Where we are here. Launching the attack. Once the attacker has obtained the authorization code, he can prepare a CSRF payload. Suppose the attacker sends an email to the victim with a link. After receiving the email, if the victim clicks on the link or executes it in his browser, where accesses the attacker's authorization code, the attacker's copy shop app or account will be linked with the victim's account. This effectively transfers all the contacts from the victim's account to attacker's victim's perspective. Wait a sec, wait a sec. In the attached VM, to practically test it as a victim, log into the client app. Let's see. We will do that in the victims app. We will go to this site, copy with the credential victim for the sake of exercise. Since the authorization code is unique, execute the what the hell? Wait a sec, guys. My plug just uh, in the attached VM to practically test it as a victim. Login, okay. Since this is authorization code is unique, execute the attacker's exploit by pasting it directly into the browser. As discussed above, the exact link sent to the victims in the URL parameter received during the preparing payload process. Once executed, the code will make the call. Alright. We need. I just messed up. Pretty bad. A sec. It is not fast, right? We need this. Uh, this much. We will copy this and we will go to victims. We will paste it here. Paste and go. Go, 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 go. Wait a sec. We will do it here. Uh, Now it will be showing here. Yeah. Now it is. We will send it. We will log in as victim. Victim. And its password is victim123. Let's go. What the hell I did wrong? Victim. Wait a sec, guys. Uh, victim. All right. Victim. Victim. Let's see. Login. Not now. Yes, we found the password flag. Account synced successfully with the accounter's account. Two messages sent. What the hell is this? We got something here. Oh ho ho ho. This maybe we sent the link, right? That one maybe. Yeah. What parameter name does the client application include in the authorization requests to avoid CSRF, that is state? STATE. Nice. Now let's go with implicit grant flow. Exploiting auth implicit grant flow. In the implicit grant flow, tokens are directly returned to the client via browser without requiring the intermediary authorization code. This flow is primarily used by the single page application and is designed for public clients who cannot securely store client secrets. However, this flow has inherent vulnerability weaknesses, exposing access token in the URL. The application redirects the user to the authorization endpoint, which returns the access token in the URL fragment. Any script running on the page can easily access this fragment. Inadequate. What the hell is that? Inadequate. Inadequate validation of redirect URIs. I don't I don't know how to pronounce this, but you can get it. The auth server does not uh, it is repeating. Let's see how to pronounce this. We are going out of syllabus. What the hell is this? All this. Wait a sec. What the hell is this?
Inadequate.
Oh, inadequate. Let's see. Inadequate validation. Me, I didn't even see the meaning. Lacking the quality or quantity required, insufficient for the purpose. Inqui frustrating.
Inadequate.
Inadequate validation of redirect URI. The auth server does not adequately validate the user URIs, allowing potential attackers to manipulate the redirection endpoint. No HTTP implementation. The application does not enforce HTTPS, which can lead to token interception through man-in-the-middle attacks. Improper handling of access token. The application store the access token insecurely, possibly in local storage or session storage, making it vulnerable to access attacks. Uh, depres- Depreciation of implicant flow. There is nothing. Due to these vulnerabilities of Auth 2.0, security best current practice recommends depreciating the implicant flow in the favor of authentication code flow. With the proof key of code exchange PKCE, the updated flow provides enhanced security by mitigating the risk of tokens exposure and lack of client authentication. Now there is a practical. Before starting the exercise, please ensure you are logged out of the auth provider as an attacker by visiting Alright, we will do that. In the attached VM, visit, let's visit that. Uh, this is victim, right? I think so. Paste. We got this page where you will see the page that allows you to sync your status from the copy shop. The authorization process will start once you click sync status button. The client application is configured to use implicit grant type, which means the access token will be directly returned to the client authorization URL constructed as follow. Client ID, client redirect URI, auth URI, URL. Let's see. Victim's perspective. Once the user authenticates using the auth provider credentials victim123, he will be redirected to callback.php where he can enter a status. This page includes from entering status and submitting Viva and Ajax request. Submit status. For demonstration purpose, the status input field is vulnerable to accesses. Once you reach the status page, enter the status like hello. It will be published. However, if an attacker exploits this vulnerability, they can inject a malicious script. Attacker's perspective. To prepare an attack inside the attack box instance, run a Python server on port 8080, alright? If you encounter a port already in use error, try please try using different port number, alright? The attack will share the following payload. Is this payload already in there? Wait a sec, wait a sec, wait a sec, wait a sec. Let's go to attack box. They said to log out. Now they are saying we need to create this server in the attack box. Let's see. I don't know. Let's see. Let's open a server. Server is running successfully. Uh, let's see what was in here. Let's discuss dissect the payload. The JavaScript payload start by extracting the fragment identifier from the URL, which is the part of URL following the hash symbol to remove the leading hash using subtract 1 to obtain the raw fragment string. And the string then splits by and symbol to separate the individual key value pairs. The reduce function process. The reduce function process each of these pairs, splitting them further by is equal to. I don't know what am I seeing right now, but I don't think so. I can understand code at this point. These key value pairs are stored in an object called result. The script extracts the access token value from this object and assign it to the variable access token. To accept this access token, the script creates a new image object as its source attribute to URL that points to the attacker server HTTP attack box IP steal token, appending the token as a query parameter. When the image is loaded, it triggers a request to the attacker server with the stolen access token included in the URL, efficiently sending the token to attackers. Copy paste the code inside the victim's machine into the status input field. Once the victim refreshes the page, SSH payload is executed. It copies the access from the URL fragment and sends it to attacker server. At the attacker can capture the token and use it to gain unauthorized. Not refresh the page in order to visualize what victims see and retrieve the token. The implicant is practically vulnerable to such attack because access token is exposed in the URL fragment, making it accessible to any script running on the page. Let's see. If we have to recreate this, we are in there. It will redirect to. Let's see if it will redirect. Uh, Authorize. Let's see. We got the access token in here. Uh, uh, I need to paste this, right? I think that is it is telling me paste submit. Let's try it. I think I did the right thing. Let's go to attack box. There is nothing. Maybe they needed the IP, right? Let's copy this. You cannot copy that. How? Let's write it here. 10.49.113.195. Uh, Copy. Let's see. Where is that? Ah, sorry about that. I know. We need the IP address in here. I need to copy here first. Paste. Uh, where it is. Paste. What the hell? Uh, let's see. Submit. I guess now it is there. It is not there. I don't know what I did wrong, how I did wrong, what went wrong. But let's hope it is in there. Why it is taking so damn long? Hmm? It is running perfectly, but attack box is not opening. Oh, what symbol separates the actor's token from the auth that is and symbol? Uh, what is that called? And not and is equal to. No, to separate the individuals as symbol. Maybe this string is then split by ampersand and I don't know. Separate the individual key value pairs. The reduce function process, there is only two options, this one and this one. But I don't know, it is not giving the answers. It's not that, and it says not hand. Maybe it is ash, but it says it is not. Which symbol separates the access totem from the which is the part of URL following removes the leading using. I don't know how it is that one, but visit the URL to enter the access token you acquired. What is the flag? What the hell? Guys, I don't know what is happening, but I got something. A sec, I will copy this. Open in your paste. We will send that. What the hell? Something it happened here. Call back. We need this token. Uh, there till there, and we will copy that. Did I copy it? Copy, and we will use this and visit the site. Server validation status up. Wait a sec. Uh, Visit the URL and enter the access token you acquire. What is the flag value? There is no. Here it is. No. Where do I put my. The hell? Nano. Nano 1, 2, 3. Let's see. Paste it. Uh, Enters. Uh, wait a sec. Wait a sec. Wait a sec. Wait a sec. We got that. Mm, from here to here. Let's see, copy. Uh, Paste. Is that the answer? Flag validator. Let's go. Is this one also died on me? Guys, we couldn't do this section, right? For some reason, what a sec, guys. Hell no. Hell no, man. Hell no. Guys, I must. Guys, forgive me for this stupidity that I committed. You need to paste the access token in here. There is the section down there where you can paste your access token. Cut where it is. Let's paste it. Submit. Server output. Guys, very much sorry. THM. What was that? Token hacked. Token HSEKED. Guys, sorry about that. Sorry about that. Again, sorry about that. Let's see how many minutes it's happened. Oh my god, already 2 hours. It is very simple. It is not much to read, but it is very much to read. Other vulnerability and evolution of Auth 2.1. Apart from the vulnerability discussed earlier, attackers can exploit several other critical weaknesses in Auth 2.0 implementation. The following are some additional vulnerabilities that penetration should be aware of while penetrating an application. Insufficient token expiry. Access token with long or infinite lifetime pose a significant security risk. If an attacker obtains such token, they can access protected resources indefinitely, implementing a short-lived access and fresh tokens helps mitigate this risk by limiting the window of opportunity of attackers. Replay attackers. Replay attackers involve capturing valid tokens and reusing them to gain unauthorized access. Attackers can exploit token multiple times without mechanism to detect and prevent token reuse, implementing nonce values and timestamp. Check wait a sec. Reply attack. Reply attack involves capturing invalid tokens and reusing them to gain unauthorized access. Attackers can exploit tokens multiple times without mechanism to detect and prevent token reuse. Implementing nonce values and timestamp check can help mitigate reply attacks by ensuring each token is used only once. Ensuring storage of tokens. Storing access token can storing access tokens and refresh tokens insecurely. Example: local storage or unencrypted files. can lead to a token theft and unauthorized access. Using secure storage mechanisms such as secure cookies or encrypted database can protect tokens from being accessed by malicious actor. Evolution of Auth 2.1. The Auth 2.1 represents the latest illustration iteration iteration in the evolution of Auth standard, building on the foundation of Auth 2.0 that address its shortcoming and enhanced security journey from Auth 2.0 to Auth 2.1 has been driven by the need of mitigate known vulnerabilities and incorporate the best practices that have emerged since the original specification was published. Auth 2.0, while widely adapted, adds several areas that required improvement, particularly in terms of security and interoperability. Major changes. Auth 2.1 introduced several key changes aimed at strengthening the protocol. One of the most significant updates is the uh, depreciation of the implicit grant type, which was identified as a major risk due to token exposure in the URL fragment. Instead of Instead, Auth 2.1 recommends the authorization code flow with PKEC for public client. Additionally, Auth 2.1 mandates using state parameter to protect against SRF attack. Auth 2.1 also emphasized the importance of secure handling and storage of tokens. It advised against storing tokens in the browser local storage due to the risk of SSS attacks and recommends using secure cookies instead. Moreover, uh, Auth 2.1 enhanced the interoperability by providing clear guidelines for redirect URI validation, client authentication, and scope validation. In summary, Auth 2.1 builds on Auth 2.0 by addressing its security gaps and incorporating best practices for offer a more secure and protected authorization framework. For more detailed information on Auth 2.1, you can reference official specification here. Is it a room? No, it's not a room, but you can read it here. Uh, it is the same one. This one that is written. Uh, which is the following has been omitted from Auth 2.4. Omitted from, I mean, I guess it is removed. That was this one. Yeah, right? It is saying here, one of the most significant update depreciation of that is correct. Conclusion. In conclusion, this room on Earth has provided a detailed understanding of Earth 2.0 and its significance in modern web application. We discussed the fundamental concepts necessary to understand Earth, including various grant types and the Earth flow. We then explored how to identify Earth services within the web application. Through practical exercise, we exploited various vulnerabilities associated with the Auth 2.0, including weak implementations of implicit grant flow, the effect of unmanaged redirect URI, and unavailability of scope parameter. This exercise highlighted the critical nature of securing auth implementation and potential risk of common misconfiguration. Finally, we examined other vulnerabilities and discussed the evolution of Auth 2.1, empathizing its improvement and how its addresses and shortcoming of Auth 2.0. This room has equipped you with a knowledge to identify and mitigate risk associated with auth from the lens of penetration, pentester and secure order. Let us know your thought on this room on Discord channel or X account to see you around. I have completed this room. Check. Nice. Stop the recording. It has only 96 points. Very bad. Very bad. Start the next. Thumbnail for try acme. We will use this thumbnail for the future, but now let's Wagyu week. It will completed in Wagyu 30 hours. That will be on 9th. I don't know, man. I typically study around 2 hours. Mm, 2 sevens are. Mm, wait a sec, guys. Do, 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 do. Let's go with 15 hours. Think that is perfect, right? What the hell? Let's try some. I don't know. Mm, Capture the flag. It is in the half. Let's do it sometime. Let's do some YouTube. I think that is the best course of action for now. Let's see. Let's see, guys. Let's go to YouTube. Mm, I need to add my, let's see, video capture device. This one, right? Uh, it is the webcam. Mm, I don't think you can see me, but how hackers hack the websites? Uh, let's see. 10 popular. What does real hacking look like? How to learn coding fast and make cool stuff. The hacking a web browser. How any website but investigating how any database using SQL injection. Investigate like the FBI using Kali Linux. Spy on any webcam using Kali Linux. Is it the webcam hacking? Who is this guy? This isn't recommended. Skytech. Oh, we watched this video before, right? Let's see this one. How they hack the.
Imagine being able to build an app with your name
What the hell?
on it, just by thinking about it. Meet Base 44.
What if I told you that one click could hand over complete control of your camera to a stranger? And what if I told you it happens through websites that
But
appear
we will
completely
not do the
trustworthy?
full site, so we have this. Wait a sec, then.
Welcome back to Tech Sky.
Uh,
Every day, millions of people click links to join meetings, view shared content, or access web applications. Most assume these sites are safe. Most never question why a website asks for camera permission. And that assumption creates the perfect opportunity for camera phishing. Before we begin, I need to make something absolutely clear. Everything demonstrated in this video is strictly for educational purposes and authorized security testing only. The knowledge you are about to gain, comes with significant responsibility. Camera phishing tools are designed for security professionals to demonstrate vulnerabilities, conduct authorized penetration tests, and raise awareness about privacy threats. However, using these tools to access anyone's camera without their explicit consent is not only deeply unethical, but illegal in many jurisdictions. All demonstrations today use only devices we own and control. Use this knowledge to protect yourself and educate others. Camera phishing is exactly what it sounds like. Attackers create fake websites that mimic legitimate services, video conferencing platforms, online meeting tools, social media features. The sites look real. The URLs look convincing. And when you grant camera permission, thinking you are joining a meeting, the attacker gains complete control over your camera. Today, we are demonstrating exactly how camera phishing works. Not so you can invade anyone's privacy, but so you understand the threat, recognize the warning signs, and protect yourself. We will use Camish, an open source camera phishing simulation tool developed.
Hamish, let's see. Is it, why the hell is this Yahoo here? Uh, no, I will change it sometime later. But what the hell? What is that? Hamish. Hamish. Let's see. Is that kind of tool? Hamish. Hamish tool. Yo, this guy is in the top. Is this guy fake? Uh, Gamish Cyber Security Tools. Let's see. There is a tool. This offers a variety of cybersecurity best practices. It is not. Does this Gamish? Let's go with this. There is this guy, Udaya Sid. Let's see.
Developed by the Tech Sky Security Research Team, specifically for security awareness training and authorized penetration testing.
Text guy.
Let's see
This
this in
is channel
action.
name.
Open your terminal and make sure your system is updated. Type sudo apt update to refresh package lists, then sudo apt upgrade to install available updates. Now we need to install Camish. Open your web browser and in the address bar type github.com/techsky-code/Camish. Scroll down and you can read about features, requirements, installation, and most importantly, ethical use.
Let's see. Gamish camera efficient simulation for education and authorized security research only. This tool is designed for the use in collaborated lab environments, security awareness training, and academic demonstration. Do not use against the individual or the system without explicit consent. What is this? Camis is a red team demonstration tool that shows how phishing pages can silently request camera access. It includes four realistic phishing templates: Zoom, Netflix, Instagram, Microsoft Team, and a full attacker control plan to manage the campaign, capture photos, and record videos from connected targets. The goal is to teach students and professionals how these attacks work so they can recognize and defend against them. Features: campaign based architecture. architecture. Create named campaigns with a custom URL, slugs, zero public route, everything expect active campaign links return 404. Randomize the panel URL. Attacker panel URL changes on every restart. These are the requirements. Python 3, you need it. Installation process is there. Uh, Terminal will print your attacker panel. When you start it, you get this skimmish camping page awareness class by text guy. Attacker panel, new every restart. Change the default password before use. Use AppPy and update attacker password to your strong password. Wow. Usage attacker workflow. Ooh, need and so. Mhm. Critical use only for authorized environments, your own lab, classroom settings. There is some, let's see what it says.
Usage guidelines. To install this tool, we need to clone the repository. Scroll up and click the code button. Copy the repository link. Back in your terminal, type git clone and paste the link. The repository clones to your system. Navigate into the Kamish folder. You can see multiple files here. App.py is the main application, along with other files. To run this tool, we need to install dependencies in a virtual environment. This keeps the tool isolated from your system Python. Type Python 3-m venv.venv to create the virtual environment. Activate it by typing source.venv/bin/activate. Notice your prompt changes, indicating you are now in the virtual environment. Install the required packages by typing pip install-r requirements.txt. The installation completes and your environment is ready. Start the application by typing Python 3 app.py. The tool launches and displays a local URL and an access password. Copy the password for authentication.
Vous avez une idée d'application web révolutionnaire? Donnez-lui vie avec Hostinger Horizon.
Languages.
Pour commencer, dites à Horizon ce que vous voulez créer.
Open the URL in your browser. Paste the password and log in. The dashboard opens. On the right
Oh,
side, you see sessions and
hell?
events
Quality dropped somehow.
tracking active connections.
Let us
Three main
access.
tabs appear. Campaigns, where you manage phishing
It's not a
simulations.
CLI.
Targets,
This is not a CLI.
where connected victims appear. And captures, where photos and videos are stored. To start a simulation, we need to create a campaign. Click New Campaign. Enter a campaign name for tracking purposes. Set a slug URL, like join-meeting, that makes the link appear legitimate. Select a template that mimics a real service. Below is a field for public URL. If running on localhost, you can ignore this. But since I am using a Kali virtual machine and want to test across devices, I need to create a public tunnel. Open a new terminal tab. We will expose port 5000, which Kamish uses by default. Type ssh-r80 localhost 5000 servio.net. This creates a secure tunnel from the public internet to your local application. When prompted to continue connecting, type yes. Serveo generates a public URL. Copy and paste it back in the campaign creation form. You can add notes describing this simulation for documentation purposes. Click the Create button. Your first phishing campaign is now active. Let's test this simulation. Copy the campaign link. I am switching to my host computer browser to simulate a real target clicking the link. Paste the link. Notice the Serveo warning page appears first. This is a critical safety feature designed to prevent misuse. The warning explicitly states this could be a phishing attempt and requires manual confirmation. This prevents accidental exposure and discourages malicious use. Click Continue to Site. Now the fake meeting page loads. It requests camera permission, exactly like legitimate video conferencing sites. I am granting permission. Since I am using OBS virtual camera instead of a real webcam, it shows my OBS logo. But in a real scenario, this would be the actual camera feed. Switch back to Kamish. A target has appeared in the Targets tab. This shows the victim connected to the phishing site. Click the photo button. The system captures a photo silently, without any visual indication on the victim's side. Navigate to the Captures tab, and you can see the captured image.
What the
Now let's
hell?
test with an actual mobile device, where the threat is most realistic. Open the campaign link on a mobile phone. The Surveyo warning appears. Continue to the site. Grant camera permission when prompted. The mobile front camera activates, displaying what appears to be a video call interface. Two targets now appear, one from PC, one from mobile. This demonstrates how attackers can manage multiple simultaneous victims. Click the photo button. The capture occurs instantly and silently.
The
The victim sees nothing unusual. Navigate to Captures, and the actual photo from the mobile camera appears. This demonstrates the real privacy threat. An attacker could capture your face, your surroundings, anything the camera sees, without any indication. Now let's test the recording feature. Set the recording duration to 5 seconds for a timed capture. Click Record. The system begins recording from the target's camera. After 5 seconds, the recording stops automatically. Check the Captures tab. The video file appears alongside the photos. Click Play to review the recording. The entire 5-second clip
that's
captured without the victim's
dude.
knowledge. You can download these captures, and they
That's
save to your local system for documentation and reporting. The Targets tab also shows a Capture All button. This triggers simultaneous capture from all connected targets, useful in penetration testing scenarios where you need to document multiple compromised endpoints. So how do you protect yourself from camera phishing?
let's see.
First, never click links requesting camera access from untrusted sources. If someone sends you a meeting link, verify the domain carefully. Zoom.us is legitimate. Zo0m.us or zoom-meeting.com are not. Second, check your browser's camera indicator. Most modern browsers show a visual indicator when your camera is active. If you see this indicator when you are not actively using your camera, investigate immediately. Third, use physical camera covers or privacy shutters. Simple hardware solutions that block the camera lens when not in use. Many laptops now include built-in privacy shutters for exactly this reason. Fourth, review and revoke camera permissions regularly. In your browser settings, check which sites have camera access and remove permissions you do not recognize or no longer need. Fifth, be suspicious of unexpected meeting requests, especially from unknown senders. Verify the authenticity through separate communication channels before clicking any links. If you found this demonstration valuable, hit that like button and hype the video. Subscribe and turn on notifications so you never miss a security
But this
tutorial.
guy's goated, bro. This guy's goated. Uh, let's see. So many email account using. Oh, my friend's email got hacked recently, bro. It's not good. This guy is legit, bro.
What if I told you that the email from your bank asking you to verify your account might actually be from a scammer sitting in another country? And what if I told you that by simply clicking that verification
What the hell happened? It freezed. What the hell?
link, you could wake up tomorrow to find your savings account completely emptied and your identity stolen. But here's the most terrifying part.
Why the hell
These
that
fake emails
Facebook?
can look so convincing that even IT professionals fall for them, leading to million-dollar data breaches and financial fraud. Welcome back to Tech Sky. Today, we're exposing one of the most dangerous weapons in a cybercriminal's arsenal: email spoofing. I'll demonstrate exactly how attackers can impersonate anyone through email, creating messages that appear to come from trusted sources while actually originating from malicious actors. More importantly, you'll learn how to identify these deceptive emails and protect yourself from becoming the next victim. Before we
Disclaimer.
begin, I need to make something absolutely clear. Everything demonstrated in this video is strictly for educational purposes only. The knowledge you're about to gain comes with significant responsibility.
Great power
Understanding
comes
email
with
spoofing
great
techniques is
responsibility.
crucial for cybersecurity professionals and individuals who need to recognize these attacks. But using these methods to deceive or defraud people is not only unethical, but illegal in most jurisdictions worldwide. All our demonstrations today will be performed using temporary email addresses and controlled testing environments. We will not be targeting any real individuals or attempting to commit fraud. Today's video is comprehensive and packed with detailed information, so grab your notebook. We're going to cover everything from setting up spoofing tools to understanding email security mechanisms and protecting yourself from these deceptive attacks. Millions of emails flow through the internet, carrying everything from casual contacts implicitly. If an email appears to come from their bank, they believe it's legitimate. If it's from their boss, they assume it's authentic. This trust is exactly what cybercriminals exploit through email spoofing. Email spoofing is the practice of sending emails with forged sender addresses, making them appear to come from someone else entirely. It's like wearing a digital mask that can make you appear to be anyone: your victim's bank, their employer, a government agency, or even their own family members. The technique has been responsible for some of the most devastating cyber attacks in history. The 2016 Democratic National Committee hack began with spear phishing emails that appeared to come from Google. Countless businesses have lost millions to CEO fraud, where employees receive seemingly urgent requests from their executives to transfer funds immediately. What makes email spoofing particularly dangerous is its simplicity. Unlike complex malware or sophisticated hacking techniques, email spoofing exploits a fundamental weakness in how email was originally designed. It was never built with strong authentication in mind. Today, I'll show you exactly how these attacks work, using tools specifically designed for security testing. Let's start by preparing our Kali Linux environment and check for the latest software information. System updates. When prompted, type Y to continue.
What the hell?
Any
What the
available system updates. When prompted, type Y to continue. This ensures our system has the latest security patches and software versions. Now we need to install a specialized tool for email spoofing testing. This tool has been developed by the TechSky Security Research Team, specifically for educational and penetration testing purposes. Open your web
system?
browser and
That
navigate
guy
to
some kind of brand.
github.com/techsky-eh/est to access the repository. As you can see, this tool is called EST, which stands for Email Spoofing Tool. It's been specifically designed to allow security professionals and students to practice email spoofing techniques without facing legal trouble, as it's intended solely for educational and authorized testing purposes. You can read the complete documentation by scrolling down the repository, but we'll perform everything practically in this video. Copy the GitHub repository link either from the address bar or by clicking the code button. I'll click the code button and copy the repository link. Return to your terminal and type git clone, followed by pasting the copied link. Press enter to begin cloning the repository. After the tool is cloned, navigate to the EST folder by typing cdest. Let's see what's inside this folder by typing ls. You can see various files including est.py, install.sh, and requirements.txt. For installing this tool, we'll use the install.sh script, but first, we need to make it executable. Type chmod plus x install.sh and press enter. The chmod command changes file permissions, and plus x makes the file executable. This is a security feature in Linux that prevents scripts from running without explicit permission. Now type /install.sh and press enter to begin the installation. The system will ask if you want to install the tool. Press Y to continue, then enter your Kali Linux password when prompted. The installer will now download and configure everything the tool needs to function properly. This might take a few minutes as it installs dependencies and sets up the environment. Once installation is complete, you'll see a message saying, "Installation complete." Let's verify the installation by typing EST in the terminal. You can see the command is recognized as the text color changes. Now type --help to see the available commands and options. This displays all the functionality available in the tool.
Did you know you can AFK Bloods and Zaya whilst learning to code in Python? Go to boot.dev. We've known our students to pull it off. Here's how. Monitor 1, code. Monitor 2, level rune crafting. Before you know it, you'll have written thousands of lines of real code and even knocked out that Karamja Elite Diary rune crafting requirement.
Before we can perform email spoofing, we need to set up a local SMTP server. SMTP stands for Simple Mail Transfer Protocol, which is the standard protocol used for sending emails across the internet. An SMTP server acts as a post office for emails. It receives messages from email clients and forwards them to their destinations. For our testing, we need our own SMTP server to have complete control over the email sending process. Don't worry about the technical complexity. EST handles all of this for us automatically. Type EST server, port 2525, to start our local SMTP server. This port is an alternative SMTP port that's commonly used for testing purposes. Unlike the standard port 25, which is often blocked by internet service providers to prevent spam, port 2525 is typically available for legitimate testing. You can see the server is now running and ready to handle our email spoofing requests. The server will log all activity, allowing us to monitor exactly what happens during our tests. Now let's explore the spoofing capabilities. Open a new terminal window while keeping the server running in the first one. EST comes with several pre-built templates that mimic real-life email spoofing scenarios commonly used by fraudsters. Type EST list to see the available templates. You can see 5 different templates designed to replicate common social engineering attacks. Each template has a unique ID number and represents different types of fraudulent emails that attackers commonly use. These templates include scenarios like fake bank notifications, phishing attempts, and business email compromise attacks. At the bottom, you can see the command syntax, EST test, ID, target, where the ID is the template number and target is the email address. Before we can test this, we need a target email address. Since we're conducting this for educational purposes, we'll use a temporary email address rather than any real person's email. Open a new tab in your browser and search for temp mail or temporary email. You'll see various websites offering disposable email addresses. Open any of these services and copy the temporary email address they provide. Now back to the terminal, let's test the first template. Type EST test1, followed by the temporary email address you just copied, then press enter. After a few moments, you'll see a message indicating the email has been sent. Return to the temporary email website and refresh the inbox. As you can see, an email has arrived. Contents. Notice how legitimate the email appears. The formatting, sender information, and content are designed to look authentic. This demonstrates how convincing spoofed emails can be, making them extremely effective tools for social engineering attacks. While the pre-built templates are useful for understanding common attack patterns, let's create our own custom spoofed email to see the full capabilities of
I don't know why, but it's freezing. What the hell, man? It's freeze it, dude.
Email spoofing. We'll craft an email that appears to come from a high-profile source to demonstrate how attackers might impersonate trusted entities. Type EST custom from email ceo@paypal.com to set our spoofed sender address. We're choosing to impersonate PayPal's CEO because financial institutions are commonly spoofed in fraud attempts. Next, we need to specify the sender's display name. Type from name John Smith, CEO, to make the email appear to come from a legitimate executive. Now let's set the subject line. Type subject urgent request. Notice how we're using urgency. This is a classic social engineering tactic. Fraudsters often create false urgency to pressure victims into press. Press enter to send the email. After a few moments, you'll see PayPal's leadership. The spoofed sender address, professional-looking sender name, and urgent subject line all contribute to the deception. If you return to the terminal running our SMTP server, you can see detailed logs of all the email activity we've generated. This logging capability makes EST valuable for security testing and understanding exactly how email spoofing works behind the scenes.
Ça, c'est ce que j'appelle de l'art. Du travail de pro.
Des outils de pro.
À vous de jouer.
Mechanisms designed to prevent these attacks, and why they sometimes fail. EST is specifically designed for testing the effectiveness of email security protocols, defenses against email spoofing, but they're only effective when properly implemented. SPF stands for Sender Policy, authorized to send emails for a particular domain. When an email arrives, the receiving server can check the SPF record to verify if the sending server is legitimate. However, SPF has limitations. It only validates the envelope from address used in SMTP transmission, not the header from address that users actually see. This means sophisticated attackers can still create convincing spoofs that pass SPF checks. DKIM, or Domain Keys Identified Mail, adds a digital signature to emails using cryptographic keys. The receiving server can verify this signature against the public key published in the sender's DNS records. DKIM is more robust than SPF because it cryptographically verifies that the email content hasn't been tampered with and that it truly comes from the claimed domain. However, DKIM can be bypassed if organizations don't properly configure their keys or if attackers find ways to relay emails through legitimate but compromised servers. DMARC, which stands for Domain-Based Message Authentication, Reporting, and Conformance, builds on both SPF and DKIM. It allows domain owners to specify what should happen to emails that fail authentication checks. DMARC policies can be set to none, monitoring only, quarantine, send to spam folder, or reject, block entirely. The protocol also provides reporting mechanisms so domain owners can see how their domain is being used in email communications. The problem is that many organizations don't implement these protections properly, or they set policies that are too lenient to avoid blocking legitimate emails. This creates opportunities for attackers to exploit these gaps. Understanding how email spoofing works is the first step in protecting yourself, but there are several practical measures you can implement to reduce your risk. First, always verify unexpected emails through independent channels. If you receive an urgent request from your bank, CEO, or any authority figure, contact them directly, using a phone number or website you know is legitimate. Don't use contact information provided in the suspicious email itself. Pay attention to email headers and sender details. While spoofed emails can look convincing, they often contain subtle inconsistencies. Check the full email address, not just the display name. Look for unusual domains or slight misspellings of legitimate addresses. Be skeptical of emails that create artificial urgency or pressure you to act immediately. Legitimate organizations rarely require instant action via email, especially for sensitive matters like financial transactions or account changes. Enable multi-factor authentication on all your important accounts. Even if attackers successfully phish your password through a spoof email, they'll still need the second factor to access your accounts. Keep your software updated, including your email client and web browser. Modern email applications include improved security features that can help detect and filter spoofed messages. For organizations, implement comprehensive email security solutions that go beyond basic SPF, DKIM, and DMARC. Advanced threat protection systems use machine learning and behavioral analysis to detect sophisticated spoofing attempts. Train employees to recognize social engineering tactics. Regular security awareness training should include examples of spoofed emails and teach spoofing attacks are detected. Here to come from high-profile executives. These techniques exploit them. Remember, the knowledge shared in this video is meant to help you understand these threats
That's it for today, guys.